Okay, in this section we are going to talk about partial fraction decomposition. So in the past when we've had a problem like this, we've had 2 divided by x plus 1 over x minus 2. We would have to come up with common denominators and then add the numerators together to come up with the red portion of our answer here. That's how we would solve our rational expressions before. Each fraction in this is called a partial fraction. So the 2 divided by x and the 1 over the x minus 2, those are both partial fractions. The red portion here, the rational expression, is actually called a partial fraction decomposition. And so what we're going to do is we're going to reverse this a little bit. Normally we'd work with the green side and come up with the red. Well, this time we're going to work with the red side and come up with the green. So we're going to reverse it just a little bit. So instead of starting with the partial fractions or the green parts to come up with the red, we're going to start with the red and come up with the green. So I'm not going to mess around with trying to get common denominators right off the bat. Okay, so let's start off with a fairly easy one. Now these can get very difficult, but I'm going to just start us off pretty easy on this one. And there's some pretty common steps to these that you're going to want to do. So the very first thing that you want to do when you're working with these problems is you want to see if you can factor this as much as you can. So the numerator on this one's not going to factor, but the denominator on this one we can see factors. So I'm going to leave the numerator alone. So we've got 5x minus 1, and our denominator is going to factor to x minus 5 and x plus 3. So that's our first step. We always want to see how far that we can factor. Now, when we're doing this, you want to factor your denominator so that your factors are linear or quadratic. So I want powers of 1 or powers of 2. If it can go any higher than that, we've got some more work to do. But most of the ones that we're going to be working with will be linear and quadratic, but you want to keep them down as low as you can go. That's what makes these things easier. Okay, so since I have 2 factors in my denominator, we're going to set this up then, and we're going to need 2 fractions to add together. So I'm going to put my first factor, that should be an x minus 5, that's my first denominator, and then x plus 3 is going to be my second denominator. And for right now, we don't know what the numerators are going to be, so we're just going to let them be constants. So I'm going to call this one an a, and this one's going to be a constant of b. What we need to do now is to kind of eliminate our fractions all the way, and we've done this before. To get rid of our fractions, we're going to multiply everything by the denominator. So we're going to multiply by x minus 5 and x plus 3. So everything is getting multiplied by the denominator. Well, on the left-hand side here, when you multiply x minus 5 and x plus 3, these guys are all going to cancel out. You're just going to leave you with your numerator. So we're going to have 5x minus 1 left over. When you take x minus 5 and x plus 3 times our a over x minus 5, well, the x minus 5s would cancel out. We would have an a times the x plus 3 left over. And then as we continue to distribute through there, the x minus 5 times x plus 3 times our last fraction, the x plus 3's will cancel out. That leaves me with a b, and then times by x minus 5. So we're going to do a plus sign, and then b times x minus 5. Now, there's a couple different ways that you can do it from this point. So I'm going to show you how to kind of do this one by hand, but there is a way to do these on the calculator as well. I'll show you the calculator ones on some of the harder problems because these aren't too hard to do. Okay, so what we've done now is we've basically turned this into linear because I don't have any fractions going on anymore. So next thing we want to do is start substituting in for our x values. Now this is kind of seems weird, but guess and check almost. But I'm going to get a little lazy right here because I'm going to use the value right here that would produce a 0. So I want to eliminate one of my variables, a or b, and it doesn't matter which one you start with. I'm going to start by eliminating a. Well, the only reason I can get rid of a is if I were to let x equal a negative 3. Because think about this. If I put a negative 3 right here, I would have negative 3 plus 3, which is 0. And 0 times a just turns into 0. So that would eliminate it. So my first time through, I'm going to let all of my x's equal a negative 3. So everywhere we have an x, we're going to replace it with a -3. And then we're just going to simplify. We've got a -15 minus 1. And we already talked about -3 plus 3 is 0. And then -3 minus 5 is -8. Going to continue to clean this up. We've got a -16 equals, well, a times 0, that just goes away. And then we get -8b here. And then when we solve for b, we get b to equal 2. So we've got one of our variables right there. So there's one of our answers so far. Okay, now we need to solve for a. Well, we're going to do the exact same thing we did. I need to eliminate b. And in order to do that, I got to substitute in for a new x value. So in order to get rid of b, I need this to equal 0. So of course, that means x has to equal 5. So the second time through this problem, I'm going to let x equal 5. So x is going to be 5. And we're just going to simplify here. So we have 25 minus 1 is equal to a times 5 plus 3, of course, is 8. Then we have b times 5 minus 5, which is 0. Keep cleaning up. 25 minus 1 is 24. We have 8a. And of course, b times 0 is just 0. Solving for a, then we get a to be 3. So now we have what our constants are. We know what a and b are. So if we go back to our original problem here, we had 5x minus 1 over x squared minus 2x minus 15. And then we said it was a over x minus 5 plus b over x plus 3. Well, now that we know what a and b are, we can substitute those in. So now I can say 5x minus 1 over x squared minus 2x minus 15 is going to equal a, we know, is 3. So I can replace the a with the 3. And b, we know, is 2. And there is our final answer. And then if you want to check these on the right-hand side, of course, you can always get common denominators and then combine them and see if you get the answer on the left. All right, let's look at one that's a little bit harder here. Same idea, though. We always start off with trying to factor as much as we can. So if we factor here, we can only take a GCF out of our denominator. Our factors are linear, so that's good. So then we're going to have 2 factors. So I know I'm going to have 2 fractions. Each fraction is going to get one of the factors. So the first fraction gets the x, and the other one gets the x plus 2. And again, they're both going to be constants. So I'm going to put a and b up there. We need to eliminate our fractions. So I'm going to multiply everything by the entire denominator. So I'm going to multiply by x and x plus 2. All right, go ahead and multiply each piece by that, and let's see what you end up with. So when we multiply through, everything cancels out, leaves me with a 5. Second fraction, the x's cancel through. I have a times the quantity x plus 2. And then our third fraction, the x plus 2's cancel out, and I just have bx left. So again, we're going to eliminate either a or b. It doesn't really matter which one you pick. If I eliminated a, I got to think to myself, what do I need to let x equal so that it's equal to 0 here? So hopefully that you figured out x is going to be a -2. So everywhere there's an x, I'm going to replace it with a -2. So we have 5 times a times the quantity -2 plus 2 plus b times a -2. So I'm just replacing all of the x's with -2. And of course, -2 times 2 is 0. And just continue to clean that up. a times 0 is just 0. And when we solve for b, we get negative 5/2. Okay, same thing. This time I've got to think about this term. What do I let x be so that I get a 0 there? That one's pretty easy. I'm just going to let x's be 0. Okay, so we're going to let x be 0. So we're going to have 5 equals a, and we're going to let x be 0. Clean that up a little bit. And then, of course, b times 0, we know is just 0, so I don't even really need that right there. So solving for a, we divide by 2, and I get a to be 5/2. So we get ready to look at our original problem. We had 5 over x squared plus 2x, and we broke that into our two fractions, and we had a over x plus b over x plus 2, and we found out that a, well, let's go ahead and rewrite the left side again so it's in correct order here. We found a to be 5/2, and b was a negative 5/2. Now, I don't particularly care for the fractions here inside of fractions. Those could be cleaned up, but this is all the farther that they're asking us to go. So they're not even asking us to reduce down these fractions inside of fractions. So this would be our final answer right here. Okay, last one, and this one gets a little bit challenging, so we're going to try this one on our calculator here. We still have some work to do before we get to the calculator part, but we'll go ahead and crank through this one. Now, this one's already been factored for me, and immediately I noticed in my denominator I have 3 factors. So this one's going to be a little bit different because I don't have 2 fractions in this problem. I'm going to be having 3 fractions in this problem. So we're going to start off by doing our 3 fractions. So we've got x squared plus 2x plus 5. And then we're going to be doing our 3 fractions here. And then each denominator gets one of our factors. So we have an x plus 2, an x minus 3, and an x plus 5. Now, because all of these factors are linear, I know we're going to get constants up here. Now, this time, since there's 3, I'm going to have 3 variables. And then we attack it the exact same way. We're going to multiply by the entire denominator. So I'm going to multiply by x plus 2, x minus 3, and x plus 5. Sorry, I got a little messy there. Okay, so when I multiply that by the piece all the way on the left here, that just cancels out my denominator. When I take it times the a over x plus 2, I know the x plus 2 is going to cancel out. So I'm going to have a times the x minus 3 times the x plus 5 factor. Erase this because this only canceled out with that middle one. So this plus 2. Right, in our middle fraction, we have a b minus 3 as our denominator. So the b minus 3 would cancel out. So that would leave me with b times x plus 2 and x plus 5. And then we have our last fraction here, so I'm going to erase that and try and write that a little bit neater in here. So we have x plus 2, x minus 3, and x plus 5. And again, the x plus 5s will cancel out. That's going to leave me with c times x plus 2 and x minus 3. Okay, we need to FOIL all of these, so go ahead and take a second to FOIL those so the left side stays the same. And then I'm going to leave the a out here while I FOIL, so go ahead and FOIL and combine like terms. I've got x squared plus 2x minus 15. And then I'm going to do the same thing with the 2 for the b. I'm just going to FOIL those. I get x squared plus 7x plus 10. And then with the c's, I get x squared minus x minus 6. And then we're going to distribute the a through that trinomial, the b through the middle trinomial, and the c through the last trinomial. So this turns into a kind of a lot of algebra right here. Nothing super hard. We're just distributing. So I have ax squared plus 2ax minus 15a plus bx squared plus 7bx plus 10b plus cx squared minus cx minus 6c. Okay, now I know this looks super messy and nothing is considered a like term, so we can't really combine anything. But what I really want to do is focus on the left-hand side here. The left-hand side has the x squareds first, and then the x to the first, and then the constants. So what I want to do to the right-hand side is just rearrange everything. So I want anything that has an x squared to come first. So the left-hand side is going to stay the same. The right-hand side, though, if it has an x squared, I want to write it at the beginning. So I have an ax squared, I have a bx squared, and I have a cx squared. So I can get rid of all of those guys. I've used all of those. And if I look on the left-hand side, my middle term is x to the first power. So the next thing I want to do is gather all of my x's to the first power. So I have a 2ax, I have a 7bx, and I have a minus cx. Those are all of my x's to the first power. And then on the left side, we have our constant, which is 5. So I just want to gather all of my constants, if you will, the ones that don't have an x variable. So I have a negative 15a, a positive 10b, and a minus 6c. Now, I know this is kind of weird to look at, but we actually have this thing written in the exact same order on both sides. Okay, what we're going to do, again, left side, I have x squared plus 2x plus 5. The right side, I want to write this as a factor of x squared. So if I'm looking just at these three, I notice they all have an x squared in them. So I'm going to factor out an x squared from all of them. And when I do that, I get a plus b plus c. And then I'm going to do that with the next set of terms. Those are my linear terms, and I see they all have an x in them. So I'm going to factor out an x, and I get a 2a plus 7b minus c. Now, our last term, even if you can factor anything out of it, we don't really need to worry about it because it's the constant. So I'm going to leave it alone. And then I'm going to do one thing as a rewrite, and that's all I'm going to do. I'm just going to let you see this. So just going to absorb. The left side is going to stay the same, and the right side I'm just going to rewrite. Let's try that one more time. So you can see all I did was move the variable at the end of the parentheses. Now, why did I bother doing that? Well, if you look, you'll notice that the leading coefficient for the x squared over here is a 1, which means the leading coefficient of the x squared here has to be a 1. So I know that a plus b plus c has to equal 1. The leading coefficient in front of my linear term is a 2. So I know that the coefficient in front of the x, the linear term there, also has to be a 2. So 2a plus 7b minus c has to equal 2. And then my constant is a 5. That has to equal the constant we have here. So negative 15a plus 10b minus 6c has to equal 5. And this is a system of 3 variables. And we're going to use our calculators to take care of these. So grab your graphing calculators. Let's enter these as matrices, and we'll enter them real quick here and solve. Okay, going to our matrix, we're going to hit second inverse. We're going over to edit, and we'll just enter them in A and B. So we've got a 3 by 3 here, and we've got 1, 1, and 1. Our second matrix, we have 2, 7, and negative 1. And then our last matrix, we have our last one, we have a negative 15, a 10, and a negative 6. And make sure and hit the enter key after that. Okay, we got to quit out of this. So I'm going to hit the second function key and then mode. And then we got to go back in and enter our second matrix. So I'm going to go second matrix, over to edit, down to B, hit enter. This is a 3 by 1. And we're going to enter 1, 2, 5, and hit enter after that. We're going to quit out of this, so second quit, and then we're going to do A inverse times B to get our solution. So we're going to do second matrix. We want A, so go ahead and hit inverse. And then I'm actually going to hit the inverse key, which is the one we use to get into matrix. And then we're going to multiply that by the B matrix. So I'm going to go second matrix and arrow down to B and hit enter. And then if you hit enter one more time, it'll kick out A, B, and C for you. So go ahead and hit enter. Now this kicked out decimals. I don't want decimals, so I'm going to hit my math button. And then enter, enter, enter. And there are my answers for A, B, and C. And now we can go back to our problem and finish writing it in correctly. So we can go back to our original problem, which was x squared plus 2x plus 5 over x plus 2, x minus 3, x plus 5. And we can substitute in A was a negative 1/3. That was over x plus 2. B was 1/2. That was over x minus 3. And C was 5/6. That was over x plus 5.